It's not fair.
Pass today's assignment in. Some of you still have the worksheet to hand in. Hand that in first, and the assignment of yesterday if you didn't hand it in then.
Are you talking about the boxes?
The boxes worksheet. If you haven't done your boxes worksheet, get that coming in. And then, those of you who didn't hand in an assignment yesterday, try to keep those two together. And then the new one that you worked on today, then pass that in, and so we can keep that quite straight. Yes?
If we don't know how to do something, we can't do it. Are you going to count us off then?
Yes, I am. Because I have some people, I've got to tweak some things in terms of what we're doing things. Because some of you are not putting enough time sweating it out before time, and they just come here and quickly do the problem in class, okay? And then you don't really learn it. So that's a little thing out there, so I'm going to work on that issue. And a couple of you want to keep your assignments, but I'll try to get them right back to you the next day. Now, some of you are handy in the worksheet. It will be available for you tomorrow. If you come in tomorrow morning or tomorrow afternoon, I'll have it available for you. Let's see, here's common stuff. Now, okay, Cameron, will you make certain that our stuff all stays up here pretty good so I can take a good look at that? Then, okay, I've got a bunch of stuff here. You want to take care of this one? And you want, would you please? Okay, now, do I have something here that needs to be distributed to you?
I'll do it.
Okay, the test for Thursday is going to be this. This is the outline for the thing. On page 4, or this section, 4.2, there are graphing kinds of things. And we've done most of those in class, and I'll ask you to do a couple of those. 67 is pretty cool, 69 is, and these are two. Okay, then dealing with worksheet. Yesterday, there were things that you didn't understand yet about the second derivative test. Okay? So, that worksheet does a first derivative test. Hopefully today, we will use that test a couple of times. We will also use the second derivative to find inflection points. That is not the second derivative test. Okay? That worksheet, bottom part, was not the second derivative test. Okay? So, make certain you know that difference. Then here, there are two problems we did using the second derivative test. Know the difference between those things. The second derivative test says, if at your critical point, your second derivative is less than 0, it's a maximum. Okay? Not an inflection point. Some of you aren't listening. Okay? Okay? And then the problems that you worked on today, 5 through 10, you will have one that's similar to that group. Okay? And we're not going to take the whole hour and 20 minutes to do that. Now, what I want to do today is to answer your questions, at least a few of them in this section, and then develop a couple of other things, and also I hope to develop part of what I want to do tomorrow in terms of a problem. Yes?
You want to take those questions now?
Let's just get started and we'll see how we roll. If I notice that I'm in trouble in terms of what I have to do, like I did to you the other day, I'll cut you off and say, okay, now I need my time.
Okay.
Okay, what do you want, Brad?
On 261, it is, let's see, number 9.
Okay. Now, when you do these kinds of problems, what two positive real numbers,
Yep.
okay, whose product is 50,
Yep.
have the smallest possible sum? Okay? Now, what's my okay, here are my two numbers.
So 50 is.
And they're positive.
Yep.
Okay? And it says x times y equals,
50.
okay, this is my constraint.
Right. I get that.
Okay, good. And now we want to add them.
And that's a small.
And you can call it any letter you want. We'll just do an S, sum, okay? And I want here that the sum is the smallest. Okay? Now what did you do?
Now, then I divided it by x on top there. I'm not sure. To get y and then.
Okay, you did it with y.
Yeah.
Okay, since you did that, I'll do it too. X equals 50 over y. That's what you did, right?
I did it, I divided by x.
Okay.
So it's y.
Okay, this is what I had understood you to say, so you did it this way, which I like better.
Yeah.
Not that it makes any difference, okay? Okay, now, this gives me x plus 50, oh, this is cool.
Yeah, okay, stop there. Okay, so you just plugged it in for that.
Okay.
That's what I was doing.
Okay, this is my object function.
Right.
Okay, now, any questions beyond this?
Yes.
Oh, okay, have you guys,
Finish it.
okay, let's finish it. So you finish your problems. Because I'm afraid some of you are not finishing the problem even though you got an answer, which matches what's in the back of the book. That doesn't mean you're finished, okay? So, I'm going to take my first derivative here, and that turns into
1 plus or minus
50 over x squared.
Why is it 1 minus?
okay, because it's x plus 50 x to the minus 1. And the derivative of that is 1. The derivative of this is 50. Oopsie. The derivative of this is 50 times a minus 1 x to the minus 2.
Is that the same as doing the, what do you call it? Low behind thing?
No,
Or are you doing?
Why is it?
no, I don't want to work that hard. No. Okay, we're having trouble right here. Let's do this over. This is kind of what my function is, s. Okay, the derivative of that is just plain 1. And now I didn't write it in the bottom. Here, I wrote it in the top. Instead of x in the bottom, it becomes a minus 1 on the top. Okay, and how do you find the derivative of that? You take, this is just your constant, 50, times what's up here, minus 1, and then it's x, and you drop this by 1. Okay?
Negative 50x.
Yes?
What if, like, I just knew that was kind of common knowledge, it would be the square root of 50.
You just knew this.
Yeah.
So did Greg.
Just calling it old.
Okay, no problem. Okay, can you go to the next one?
So I didn't show all the work like that.
Hey, I don't have a big problem.
Okay.
Some of you have that stuff down good enough, so Lucas, great. I'm all for it. But if you have to go this far, do it, okay? Now, we need that equal to 0, right?
Right.
Okay, so I get here 50 over x squared equals 1. Or x squared equals 50. So x equals,
Square root of 50.
yes, which is 5 times the square root of 2.
Can you pull down the screen?
Okay, there's an x
Oh,
squared.
yes.
There.
Okay, is that what one of the answers is?
Yes, that's both of them.
Both of them. Okay, now, that's nice. So we've got that. But, is this, am I finished? No, I'm not finished. I did, okay, so
Second derivative, right?
I need to apply the second derivative. Or I have to use the first derivative test. Okay? So, now, Greg, can you give me this one? What is the second derivative of this thing?
X over x
See that?
How?
Okay. Now, what we have here, I'm going to do this little piece over here again. This is, I'm just going to do this part here, which is a negative 50 x to the minus 2. Now, this is not quite right. Okay? So, this becomes a minus 50 times a 2 and x to the minus 3. See, so this should be a 3. And
So
then,
it's 100.
okay? Now, So at this point, I'm going to use the second derivative test, which is putting my critical number in here. I'm going to do S double prime of 5 times the square root of 2. I put that in here, and is it positive or negative? That's positive. If it's positive, then this point over here, what we're talking about, is a relative minimum. Okay? And that's what we're supposed to find. What's the smallest possible sum? Yes?
So like in the book, when it gives examples, it has you plug it in the 5 square root 2, but then also the endpoints of the, where the, like the ends of the interval.
Yeah.
Why do you do that?
Okay. I will show it to you maybe toward the end of the period in more detail. But you don't have that in any of these problems, did you?
Well, just like that's how the book says to do it for all.
Okay, yes. Because sometimes you have some constraints that x's can only be from one length to another. I have a problem pretty soon that's going to be 6 miles long and $60,000 a mile. And therefore, you're going to have some constraints, and you're going to have to take a look at the endpoints. If those would possibly give you a max or a min. Because your maximums, absolutes, we're talking about absolutes now, they're going to happen at endpoints or at your critical points. That's where they're going to be. And you have to check the endpoints to see if they're there. Okay? Next question. Yes?
Never mind.
Good one.
10, again. Yeah, do what Common said.
What did he say?
Or,
Number 10. Okay. So here we go with 10. Which part of 10?
Both parts.
A, start with A and then
Okay.
B.
Now, we did this in class yesterday. Hey, guys, we did this in class yesterday. And in this case, we have a barn and a rectangular pin, one side against the barn, 200 meters of fence are used for the other 3 sides of the pin. Okay, oh, okay, now I get it. Here's one side, here's another side, and here's the other third, this is the third side. Okay? Now, you want to call this side X? Therefore, this is going to be X, and this is Y. What's my constraint? 2X plus Y equals 200. Okay? That's my constraint. Now, what's the area of that pen?
100
No, it's not.
on 10.
It's X times Y. Okay, this is my object. The object of what I'm trying to do. And now, do I want the smallest pin?
No.
No. You want the largest. What would be the dimensions of the smallest pin?
1 by 199.
Yeah, 1
Wait, no.
100
by 198.
by 0.
Oh, that works.
See, that'd be a fence this way and right back like this.
Oh, nice.
Or it could be 0 by 200. Dumb. Yeah, then your fence is just, doesn't have any area. Okay? Okay, now here we go. And we're going to solve for that. So my area now becomes X times 200 minus 2X, which is equal to 200X minus 2X squared. The procedure at this point, pardon?
So now you take the derivative?
You take the derivative of it. Why? What do you want the derivative?
Because you want your
The back.
objective prime.
Okay, I want the critical points because my maximum momentums always happen at endpoints or at critical points. Okay? Now, the first derivative will give me
The
critical points. Okay? So, I'll do that in a minute. That's pretty nice. That's 200 minus 4x, like this.
Yeah.
So the critical point is x equals
50.
50. Okay? Now, I'm gonna doodle over here for just a minute. If this side's 50, this side's 50, this side is going to be
100.
and so my dimensions are 50 by 100. So that gives me 5,000, I think it's meters squared, isn't it? Okay, now what happens if this is going to be 49? This is going to be how much?
102.
102. And that's going to be 4,998. Okay, what happens if this is 51? Now let's make it, 51.
98.
98, and this is going to be 4,998, I think, if I'm doing my math in my head right. Okay? Those are both smaller. Okay? So that seems to be an indication. That's not my test. This problem is very easy to do a second derivative test. Okay? So I'm going to do my second derivative test, and I'll do a double prime. And that's going to be equal to?
-4.
And that is a positive or negative number.
Negative.
And a negative number is going to be,
Maximum.
yeah, a frowny face. Okay, frowny face, so there's a maximum over here. Yes?
Did you do B
Yeah.
as well?
Okay.
Yes, sir.
Okay, that will probably have to be it for today. B part, we're gonna divide that fence into how many parts? 4.
Is it the same fence that we just built?
No, I don't think so. A rancher plans to make 4 individual and adjacent rectangular fences against a barn. 4 identical, that's an important word, and adjacent rectangular fences against a barn, each, it doesn't matter. Each with an area of 100 meters squared. Okay? So here we go, like this. It's quite a different problem. And we'll come this way, and it has 4 of them. So we'll go this way, like this, and like this. And the area of this one, area equals 100 meters squared. Okay? Can we make this side X again?
Sure.
Okay, now, I could make this whole side Y, but I think I'm gonna go make that one Y. I think it's really easy. Y, Y, Y. Okay? Any questions on that? It will go both ways, I think. Okay, now, what's the area of this thing? Okay. The area equals X times 4Y, like this, and that's my object. What's my constraint?
X plus
Y equals.
Okay, my constraint, what did you say, Trevor?
equals 4y plus 5x.
4x is 5x over 100, right?
4x?
No, no.
4x plus 4y is equal to 400.
Yeah, kind of.
X times
No,
it's 4x plus 4y.
Do you want to really go that far?
What do we just?
Okay, I think you are right. But how about just doing this? X times Y equals 100? Yeah, okay. X times Y equals 100.
That's an area.
No, because that's, but you want to find all.
Okay, let's go back.
If you find one of them, you can do. Oh, yeah, okay, that works.
Okay, because some of you did a number of them, but one is good.
Isn't that the same thing though? 4x plus 4y is equal to 400? No. Or times.
I'm not sure.
4y, what did you say?
Well, yeah, it's the same thing because you just divide 4 and it's x, y.
Okay, now, here we go. This gives me equal X times 4 times 100 over X, correct? No, no, no. That's not right. This gives me Y equals X over,
Whoa.
100.
about where-ish?
Yeah, you're alright. That's right, isn't it?
Yeah.
But you should, but shouldn't it be 4x and then 100x over x?
Give me a right.
Now, it says here, what are the dimensions of each pin? I have the wrong objective.
Oh boy. Oh boy.
And that is going to be what? how about this? Fence or perimeter is equal to 5x plus 4y. Because, okay, okay?
I don't get that.
Because there are 1, 2, 3, 4 y's and 1, 2, 3, 4, 5 x's.
Because why is that your objective though? Because that would also be your constraint.
Okay, Chanel, the reason I got this is because I tried that area business and I got just a constant number and that was bad news.
And it didn't work.
No, it didn't work. And so, that's why we have to have this. Is this, did you do it this way, Homer?
No.
No? Okay.
I use the whole side as y, and then you y divided by 4.
Okay, okay, that'll work. Okay, now, this gives me perimeter equals 5x plus 400 over x. With me? Prime. With me? And so it's my critical number.
With the triple deal. I used to be able to make a circle.
Okay? 4 times, is that what you have to?
Yeah, and 0.
Okay, and so now, if that's the case, what is y
There's
equal?
only one L.
Okay? This is what x equals. Here's the constraint kind of thing.
Well, I just want to have.
So this is going to equal 100
Over the square.
over 4 times the square root of 5. And this gives me 25 like this, right? So this gives me
25 over radical 5. So then you get.
so it's 5 times radical 5.
Can you do that again? How'd you do that? Yeah. the y-
Yeah, that's right.
You have this number here, 4 times the square root of 5. And so I put it into this statement right up here.
Okay.
100 over 4 times the square root of 5. 4 goes into that 25 times, and then you can go square root of 5 over the square root of 5, and these two go out with this 5, so there's your answer. I don't know if this is a correct answer. Probably is. Okay, now, is this going to give me my maximum? Second derivative test is equal to
2x.
what? That's a 0.
2x.
And so we have here, looking at this, 400 negative x to the negative 2, which would give me a positive 800 x to the third. Okay?
Why would it
Negative third,
Negative
would it be over,
Negative 3.
so it would be 800 over x to the third?
Yes. Okay, so this is going to give a, and so now, we contend that the area of each of those, the way we did it, would be 4 times the square root of 5 times 5 times the square root of 5. Does that equal 100? It does, which is kind of amazing. This one has a new wrinkle. That's what's interesting about teaching a new book. One thing I really miss in this book is the Fibonacci groups. The book just doesn't have it. There are a couple other problems that I miss. So 5 square root of 5 times square root of 5 is 5. 5 times 5 is 25 times 4 is 100. So there we go. The size. Okay? Now, then today, the author does this one, which is a very typical one, using an airline issue. And what is the carry-on baggage one? And this happens to be on top of page 259. 259. And in that case, the girth that they talk about, that they can have, is 64 inches.
What is,
And so you have this this container like this that you have, and we'll do this way. And we measure this way, and this way, all the way around. And that can be 64 inches. Okay? Which he says here, the sum of the length, width, and height is 64. So, and then in this problem, to make it a little easier for us, he says two of them are going to be the same, and he wants this here and this here to be the same, and this is something else. Okay? Now, we want to make this thing, so we have the greatest volume. The greatest volume. Okay? Now, the volume of that thing is going to be W squared H. Okay? That is my objective, to find that. My constraint. And that's going to be 2W plus H equals 64 inches. Okay? Or my volume equals W squared times 64 minus 2W. You with me? Okay? H is equal to 64 minus 2W. And so this becomes 64W squared minus 2W cubed. And the first derivative of that is equal to 128W minus 6W squared. Okay? And now we're going to set that equal to 0. Okay? And so we get here 6W squared equals 128W. Divide by 6W. So W could be equal to 0, but that doesn't make any sense. And so this is going to be W. And this gives me 6 goes into there. 24. Not.
No, sorry.
21.333.
21 and a third, right?
Yeah.
Or he has, 20.3. Okay. Any problem with that? Now, that's going to be your W, and from there on you can get H to get your dimensions. And then how about the test? And the author often just says first or second derivative test, and he doesn't give a lot of detail. Okay? And I'm going to expect some detail from you guys. So, let's just go to the second derivative test, and this doesn't always work. In fact, the next one I'll do probably, I don't think I'll get all the way, but I'll give it a try. Okay, so this is going to be equal to
128 minus W.
Okay, now, if I put 21 and a third times 12 is going to be how much? Is that going to be bigger or smaller than 128?
Oh, bigger.
Times what?
Okay, am I going to give positive or negative number here?
Negative.
Negative.
We get a negative. 128 minus 12 times 21.3. That's a negative number. Okay? So, since it's a negative number, it opens down.
Yeah, it's a
and I have a
maximum.
maximum, so that will give me my biggest container.
What will give it when W is equal to 21 and a third?
Yes.
Okay.
Okay? Now, the next one we're going to work on is this. Now, the book does not do a very nice job with this one, in my opinion. This comes on the top of page 260. And I don't like what's all there. It is so difficult, I think. I can get through it, but it doesn't do what I want it to do. Okay? What I'm going to do with you now is going to help you solve problem 31, which will be assigned on Thursday. Okay? So you might want to take some notes here. We won't get finished with this. We'll just get good start. This is the situation. I have a nice, and this is for engineering students. For those of you who are looking at engineering, this is what it's all about, or nice chunk of it. Okay? We're going to have a little river over here, and it's gonna be a ½ mile wide. Okay? We're gonna have a power plant right over here. Okay? 6 miles down over here, I'm gonna have a factory. I'm saying this is engineering, but this is also architectural stuff. Okay? Now, a couple other things in the story. It costs $60,000 a mile.
Wait, sir, can you remember which one are you doing now?
Example 3.
No,
Or no.
this is
no,
out of my head.
bad.
Oh,
It's
okay.
in-
Okay?
It's 31 on these.
Okay? And it's gonna help you do problem 31.
Okay.
Okay? Now, I want to get power from here to over here. Now, one way I could get the power over here is to go like this and then straight across like this. This happens to be 6 miles. Okay? Now, over land, this is what it costs to lay the cable. Okay? That much per mile. Okay? Going underneath here and all the other stuff that has to, that's going to be $80,000 a mile. Per mile underwater. Okay? Makes some sense. Now, which way, how should I do this in order to get this job done? So I'm going to give you my extremes before we do the problem. Okay? Because what I think we should do is to go across the river at an angle here like this, somehow, like this, that way, and then lay it this way, okay? And then from this point over here, okay?
That's the second option?
That's the third option. The first option, oh, I didn't even give you the second option. That's doing it across like this. This will be the shortest distance, okay? Okay, we'll just do this one like this. And now, what we're going to spend a little bit of time today is to get, okay, now you've got the 3 options. The brown one from here to here, or the blue one from here to here. And now, so you get a little bit of a feel for the problem. What is it going to cost for us to go from here to here to here?
$400,000.
How much?
$400,000.
$400,000. How do you get that, Jeff? Oh.
6 times 60,000 and $40,000 for the ½ mile across the water.
Now, Jeff, okay, the blue one cost, and he said it's going to be 400,000, didn't you? Did you hear how he explained it? Okay, so that was nice. I like that. Okay, now let's do the brown one. And what we're going to do is this. It's all basically going to be underwater. Okay, it's all going to be at this price. Okay, so this from here to here and to here. So this length is going to be the square root of what?
36.25.
Yeah.
Degrees. I liked it. Plus 1/4, right?
Yeah.
Okay, and De Vries says this length is equal to 6.02.
Yeah.
Okay, very nice. I didn't expect we were going to get this far so fast. Thank you for really participating. Okay? Pythagorean theorem. Calculators, they're really fast. So the brown cost is going to be what?
481,000.
481,000 roughly. Okay? Significant difference. And when I looked at it, I thought, boy, this is not much longer than just this. But this here really adds up. Okay? Now, the next thing we're going to try to do is to figure out that orange one. And that's going to look like this. Does anybody have a pressing question before this? No. Okay, we're going to stop when the bell rings or close to it. And but here we go. What we're going to do is call this length x. What's this length from here to here then?
6.
No, hey, if you're not following that fast, because you guys are really quick, okay? So, now, this is how the cost is going to be. From this much, 6 minus x, how much is that going to cost us? 6, okay, like this, okay? And then this length, what is that length?
X squared plus 1 half.
X squared plus 1/4.
Times?
When do you
It should be 1/4, not 1/2.
How do you get that?
Pythagorean
Pythagorean
theorem again.
theorem.
Pythagorean theorem. This side squared plus this side squared is equal to this side squared. And then I took the square root of it, so I have the actual length. Okay. Okay, everybody with us now? Oh, man, are we moving? Okay, now, I'm gonna do a couple things here. This is gonna be the cost. Okay? Length, cost per mile, length. Now, I'm gonna just divide both sides by 10,000. And then, okay? Any problem with that? Makes it a lot easier, okay? Now, so the next thing I'm gonna do is do C prime, okay? And so, right down here, I'll go 36 minus 6x plus 8 times x squared plus 1/4 raised to the 1/2. See that? Okay, now, the derivative here is going to be negative 6 plus 8 times 1/2 times x squared plus 1/4
To the negative 1/2
times, DeVries says,
2x.
times 2x. Are you with me? Okay, now we'll simplify that. A minus 6 and this here one and this here we'll take them out that way. So I'm going to have here plus 8x over the square root of x squared plus 1/4. Are you with me?
Yeah.
Now, okay, we did all this nice stuff. What are we doing this for?
Yeah.
Find critical, yeah.
Minimum.
We're looking for the critical number. How do we find the critical number of this? That equals 0.
Yeah.
Okay, so I'm going to have here 8x over the square root of x squared plus 1/4 equals 6. Or, am I happy at this point? Okay, I hope so. Yes, I am. Okay, I believe I'll just start here. We're going to keep going. I've got enough time to do some significant work here yet. This equals 6 times the square root of x squared plus 1/4. Are you with me?
Yeah.
Okay, now, what can I do to solve this? Square both sides.
Yeah.
Okay, so before that, I'm going to divide both sides by 2 first. So this is going to be a 4 and this is going to be a 3. Okay, now I'm going to square both sides.
16x squared equals 9. X squared plus 1/4.
Are you with me?
Yeah.
Okay,
So 7x
now,
squared equals
okay,
4.5.
Derek, you're really moving here. He says this is x squared equals
4.5. Or no, that's 1/4, so 9/4.
Equals 9/4. Are you with me?
Yeah.
And then divide by
Oh
7.
man alive, this is fast. So this gives me x squared equals 9 over 28. With me? Okay, then now x has to be positive. So we dump the negative, just take the square root, and this is going to be 3 over 4 times the square root of 7. No, it isn't either. 3 over 2 times the square root of 7. Okay, now just a second, guys. Tomorrow I'm going to start here.
Yeah.